Hello and welcome to Lesson 2-3, Biconditional Statements and Definitions. A biconditional statement is a statement in which the hypothesis is true if and only if the conclusion is true. So that is our key phrase right there, if and only if. The sentence below is an excellent example. Two angles are supplementary if and only if their degree measures add to 180 degrees. So notice, rather than having an if-then statement, we have an if and only if statement. There's no then in the middle and there's no if at the beginning. Biconditionals are used really to make good definitions. The statement above perfectly summarizes what it means to be a supplementary angle or be a pair of supplementary angles. Biconditionals can always be rewritten as two if-then statements or two conditional statements. So, for example, in the phrase above, I could have written, if two angles are supplementary, then their degree measures add to 180. Or I could have written the converse of that statement. If the degree measures of two angles add to 180, then they are supplementary. Sometimes it's impossible to form a biconditional statement. So, for example, two angles that form a linear pair are adjacent. Well, let's look at my conditional and converse of that statement. My conditional would be if two angles form a linear pair, then they are adjacent. Which is in of itself a perfectly valid sentence, right? That's completely true. That is a true conditional statement. However, if I look at the converse of it, if two angles are adjacent, then they are a linear pair. That is false, because while all linear pairs are adjacent angles, not all adjacent angles are a linear pair. I could even draw a counterexample for this. Right there, I've got two angles which are definitely not a linear pair but are adjacent. So we found that we cannot form a biconditional because the truth value of the conditional is not the same as the truth value of the converse statement. So biconditionals can only be formed if the truth values of the conditional statement and the converse statement are the same. So now I want you to go through and try this example right here. We'll go over it in class together. Now we're going to take a look at the symbolism for biconditional statements. So we've been symbolizing conditional statements as P arrow Q, right? And then we symbolize converse statements as Q arrow P. Well, it would make sense that if both of them are true, I could use this double arrow notation to symbolize the biconditional. So P double arrow Q would mean P if and only if Q. We can always form a biconditional statement anytime the conditional statement and the converse statement have the same truth value, which is why we're able to use that double arrow. It's true both ways. So let's take a look at biconditionals in the context of definitions. A biconditional statement, they're great for writing definitions because they have to be true forwards and backwards. A good definition can always be written as a biconditional format because a good definition should work both forwards and backwards. So let's take a look at a good definition. A penny is a coin worth 1 cent. Well, I'm going to write that as a conditional. If a coin is a penny, then it is worth 1 cent. And then I'm going to write the converse of that statement. If a coin is worth 1 cent, then it is a penny. Okay, both of those are true, so I can form a biconditional. Remember, I don't start with if, I start with, oh my gosh, guys, let's spell this morning, shall we? A coin is a penny if and only if it is worth 1 cent. Boom. That's my definition written as a biconditional. Now I want you all to go through and do this try me example on your own. I can also determine whether a definition is a good definition by testing it to see if I can put it into 2 different conditional and converse statements. So for example, a fish is an animal that swims. Conditional, if an animal is a fish, then it swims. And my converse, if an animal swims, then it is a fish. Well, looking at this right now, I can think immediately of many animals that swim that are not fish, beginning with you and me. Humans swim for fun, usually, but are not fishes. Are not fish. So that's a way for you to test to see if a definition is a good definition. If it's not reversible, it's not a good definition. So now I want you guys to go through with this try me and determine, are those 2 statements good definitions? All right, guys, thank you very much. Be sure to do the MML practice homework, and I will see you all in class. Thank you.